So today we're going to continue our talk of proportional relationships with determining if quantities are proportional by graphing them. So our talk today is going to revolve around the same concept of last lesson, but now we're going to be graphing the data to see if the relationships are proportional or not. So to begin, we're going to start with some review of vocabulary. This slide will be on my website as well as in your text. So maps have grids that locate cities. This is much like the coordinate plane. The coordinate plane is a type of grid that is formed when two number lines intersect at their 0 points. The number lines separate the coordinate plane into 4 different regions called quadrants. So right down here we have an example of the coordinate plane. I'll call it CP for shortness sake here. Okay, so again, this is the coordinate plane that I'm looking at. Alright, and on the coordinate plane we can graph points using ordered pairs. An ordered pair is a pair of numbers, for example, like 1, 2, used to locate or graph points on the coordinate plane. So in the point 1, 2, we know that 1 would be considered the x-coordinate, and y would be considered the y-coordinate, and these coordinates correspond to numbers on the axes, and they determine the movements that I'm going to make in order to graph that point. So on this coordinate plane, we have some important information on here. We have an ordered pair, we have an x-coordinate, we have a y-coordinate, and we have some other information down here. So let's start with the information on the right that's in pink. The point 1, 2, that is our ordered pair. And we know that it has an x-coordinate of 1 and a y-coordinate of 2. The x-coordinate of 1 says that I start at the origin, I go 1 to the right since it's positive, and I go up 2 for my y-coordinate since that's also positive and plot my point right there. So that is how I graph. That's a little bit of a review. Next class, I will definitely go over this if we feel like we need to spend more time on the coordinate plane. But again, review, the coordinate plane contains an x-axis, a y-axis, and the origin, which is the point 0, 0, and that's where all the points originate from. So knowing that information, when we go through to graph our data points today, we will need to be using the coordinate plane quite a bit, so it's good to review this information. Let's keep moving. Alright, example 1. The slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. This problem asks us to determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane, and then it asks us to explain our reasoning. So we're going to follow a 2-step process, which is going to get us to the last step, which is always to give our final answer. So the first thing that we always need to do is to organize our data. So in order to organize our table data here, the easiest way to always do this is to make a table. This is what we did with the last lesson as well. So we know we have a time and then a distance that's covered. Well, we know at 0 minutes the sloth has not moved at all, so he has moved 0 feet. But after each minute he moves 6 feet more. So after 1 minute he's moved 6 feet. 2 minutes he's moved 12 feet. 3 minutes he's moved 18. 4 minutes he's moved 24, and so on and so forth. So step 2 for this particular situation is going to ask us to graph the ordered pairs, time to distance, and then connect the pairs with a line. Now, I know that I always put time on the x-axis. We'll talk more about this when we get to independent and dependent variables, but for now we want to remember that time always goes on the x-axis. And you'll notice that the values on my y-axis, I have scaled my y-axis by 4s in order to fit all of my data points in. So my y values have been scaled by 4s. Okay, so I graph all of my points. I have the point 0, 0, 1, 6, 2, 12, 3, 18, 4, 24. I connect with a line. Now, in order for a relationship to be proportional, 2 things need to be true. It needs to graph as a straight line, and it needs to pass through the origin. In this case, I know that the line passes through the origin and it's a straight line. So the number of feet traveled is proportional to the number of minutes. Let's try one of these on our own now. Okay, we're going to try quite a few together. So let's keep moving though. Before we do that, we're going to recap, and you can certainly pause this video and copy this information down. But to figure out if a relationship is proportional using a graph, whoa, I didn't mean to move that. To figure out if a relationship is proportional using a graph, 3 things need to be true. 2 things need to be true, and that is that the line needs to go through the origin and it needs to be straight. We follow this 3-step process to answer each of these types of questions when asked to determine if a relationship is proportional using the graph. Okay, so at this time, like I said, feel free to pause the video if you want to take this information down. But let's get into our first example. Okay, so our second example, but our first one where we actually have to produce the answer. So a hot air balloon is at 140 feet and descends at 20 feet per minute. To determine whether the height of the hot air balloon is proportional to the number of minutes, and then we need to explain our reasoning. Well, we just went through an example similar to this, where we know that our two data points are going to be time and distance. And I know that my time, we'll abbreviate distance for and then our time we know is going to be in minutes, and our distance or our height is going to be in feet. Okay, so looking back at our information, we know that if it's descending, it's going down, and whenever we go down in math, that typically means that we subtract. Okay, so we know that the hot air balloon at 0 seconds has not moved at all, so it's at 140 feet high. And then every minute it descends 20 feet, meaning it goes down 20 feet. So that means after 1 minute, it's at 120. After 2 minutes, it's at 100. After 3 minutes, it's at 80. And after 4 minutes, it's at 60. So in order to determine what this information will look like on a graph, I'm going to want my ordered pairs. So I'm actually going to write my ordered pairs. This is a step that you don't have to take, but I'm going to take it just so you guys can see where I'm getting the information that I put on my graph. So I know at 0, the height is 140. At 1, the height is 120. At 2 minutes, the height is at 100. At 3 minutes, the height is at 80. And at 4 minutes, the height is at 60. So there's my ordered pairs that I can graph. I know that time always goes on the x-axis. In this case, I can scale my x values by 1s. And I'll be able to fit all my data points. So I know I go up to 4. Now typically you just need to label the first couple, but we're going to label 4 since we only go 4 out. Now for the distance, which we know is calculated in feet, so time was minute and distance was feet, I'm actually going to scale my graph by 20s in order to fit all my information in. So I'm only going to go up to 60 for time's sake. Alright, so let's go ahead and start graphing these. I know at 0 minutes I was at 140 feet high, so that's going to be 20, 40, 60, 80, 100, 120, 140, so I put that right up there. And at 1 minute I was at 120. At 2 minutes I was at 100. At 3 minutes I was at 80. And at 4 minutes I was at 60. So then I need to connect those with a line. So I would get a ruler out at this time. I'm going to get my straight line function out right now. Okay, I'm going to straighten that line up just a little bit so it goes through the points. There we go. Alright, so I have my line, and now I need to determine if this is proportional or not. Well, one of the stipulations is met, and that is that my line is straight. However, since it does not go through the origin, I will say that this is not a proportional relationship, so no, the height of the balloon is not proportional to the minutes. Because in this case, our balloon is going down. It doesn't go through the origin when I graph its data, so it is not proportional to the minutes descending. You know, and we won't do this for every example, but we could look at the data and we could realize that 0 out of 140 not equal to 1 out of 120. So right there, if we use the information from the last lesson, we know it's not a proportional relationship. Let's keep moving with this. Now, this next situation is pretty interesting. This table shows the number of seconds and the number of times a ride at an amusement park rotates. Determine whether the number of rotations is proportional to the number of seconds by graphing. So I'm going to start straight ahead with my ordered pairs. I've got 0, 0, 5, 2, and then 10, 5, and 15, 10. And the interesting thing that we're going to notice here is this graph is not going to be a straight line. It does go through the origin, but it is not going to be a straight line. So I know on the x-axis for time, because that's going to be our time right here, all right, I'm going to want to go by fives, so that's going to be time. And I want to scale that by fives just because our numbers get so high there. So 5, 10, 15. And we know that on our y-axis, since we only go up to 10, so we can say rotations. I'm going to abbreviate it with rot. Okay, I can go up by 1. So that's 1, 2, 3, and we would keep going from there. Okay, well, I've got a point at 0, 0. I've got a point at 5, 2. I've got a point at 10, 5. And I've got a point at 15, 10. If I take a look at these values, even if I were to take a ruler, the ruler wouldn't go straight through. This relationship here is actually going to curve. All right, so we would say in this case, again, that this is not a proportional relationship. Okay, so we would say no, the number of rotations is not proportional to the time because the line is curved. Not a straight line. It does go through the origin, but unlike the last one, it is a curved line. Okay? So let's try looking at another situation. All right? We have the cost of renting video games, and we have a table determining what the cost of renting the video games is per video game. So if we write the two quantities as ordered pairs, we find that for every one video game it costs $3, for every 2 games it costs $5, 3 games cost $7, and 4 games cost $9. The second thing that we need to do always is to graph. So in this particular case, we know that the cost is going to depend on the number of games, so we put the cost going up the y-axis and the number going across the x-axis. So I've got x and y here. Luckily this time I can scale both of my lines by 1s, so I don't even need to write my scale down here. Okay, so I know that 1 game costs $3. I know that 2 games cost $5. 3 games cost $7, and 4 games then cost $9. When we go to graph this line, again, we're going to have an interesting situation where the line is not going to go through the origin. So we do not have a proportional relationship here, okay? And furthermore, the ratios are not constant. 1/3 is definitely not equal to 2/5. So when you go through these relationships, whenever we do our assignment tomorrow, all right, you're going to want to make sure that if you are not sure about your line, because whenever we look at our line down here, it could possibly, if I was messy, go through the origin. So you're going to want to make sure to check that if the line, if the numbers are going to create a proportional relationship or not using your calculations. All right. So if we take a look at example 5, which batting cage represents a proportional relationship between the number of pitches and cost thrown? If I take a look at these two numbers for these two lines, I've got softball plus, and then in blue, and I've got my fun center in red. And if I look at these lines, I'm looking for which one of these lines goes through that's right, the origin. So in this case, the fun center is the line that shows a proportional relationship. So the fun center, okay, represents a proportional relationship between the number of pitches and cost because its line's graph goes through the origin. So in that case, we know that if the line does not go through the origin, again, like the blue line here, it does not create a proportional relationship. Okay, so let's go straight to your problem of the day. All right, so tomorrow when we come into class, this is the first thing we're going to start with, and we will get right into our assignment. Okay, so have a great day. I'll see you tomorrow.